Perfect. So I will talk about tardigrades. And for those that of you that don't know what is a tardigrades is a microscopic animal. He has a cylindrical body with a not well structured head and 4 body segments that each one has a leg, and the extremity of the legs there are the claws. They have an external cuticle. They belongs to the Ecdysozoa, so they have to change cuticle each molts. They can be found all over the world, colonizing marine, freshwater, and terrestrial habitats from Arctic to Antarctic, from high altitudes like Valeria just showed you, to deep sea, and from desert and forests. They are quite known because they can withstand very extreme environments, but tardigrades are aquatic animals, so they need a film of water to surround the body to be active. So how they were able to colonize terrestrial habitats? Because they are able to dry or freeze together with their substrates. It means that they have the ability to survive environmental stressors. For example, here is the process of dehydration. So when they are in active state, they can lose water for evaporation, and they lose most than 95% of water, becoming like this. So we call that this is a dry tan state. But and when they are in this anaerobiotic state, they can suspend the metabolism, so they like dead. But when the water becomes available again, when the stressors stops, ends, they are able to return to active life. And when they are in anhydrobiosis, so when they are dry, they can stay dry for more than 20 years in atmospheric condition, or more than 30 years when they are frozen, for example, within a refrigerator. They have been called the toughest animal on Earth, because when they are dry, but we saw that also when they are alive, they can survive very extreme conditions. So when they are dry, they can survive to very high and very low temperature, very high and low hydrostatic pressures, or toxic chemicals. And alive animals, as the dry one, they can survive to very high doses of different kind of radiations. So we were interested to study the responses of tardigrades to the effects of global warming, to see if this withstanding capacity were in some way involved in the process of withstanding this increasing of global temperature. So we participated to a 5 years long field-based artificial warming experiments, in which 12 open-top chambers were heated. Here is the tubes from which the warm air hit the soil, and the temperature was increased from 0 to 5.5 degrees. Here you see the patterns of the temperature in the different chambers. The blue one is the external air temperature, and the color are the different air temperature within the chambers. And here is the situation about the soil moisture within the chambers. We evaluate 3 community diversity indexes: the abundance of animals, total abundance, species richness, and Shannon diversity index, together with the abundances of the 3 most abundant species that we found in the samples. And we related these parameters to air temperature, soil moisture, and the interaction of these 2 physical parameter to the indexes that we were interested with. We found a total of 1,800 tardigrades belonging to 13 taxa. And with quite surprise, we found that this long-term warming, 5-year warming, Remember you that did not affect any indexes or any characteristic that we were looking. So the abundances, the richness, or the diversity of tardigrades didn't change with the increasing of temperature. While other invertebrates that were in the samples were affected positively or negatively by the warming, tardigrades doesn't seem that were affected. So these results on tardigrades are in line with previous experimental studies on the impacts of climate change. Especially we study Antarctic tardigrades. Also, we saw that in Antarctic tardigrades, the the increase of temperature could not have a big, could not lead to a big problem for the species, indicating that tardigrades may not be directly affected by ongoing global warming, probably due to their thermotolerance, so they can withstand very different increase or decrease of temperature, and cryptobiotic abilities, so the capability to dry and to freeze. And also probably the buffering effects of the soil, of the leaf litter, can reduce the effect of this increasing in temperature. So tardigrade potentially can survive. We have to see if the environment, the habitat, change due to the global warming. Thank you for your attention. I hope that the time is
perfect, Roberto.
Okay,
Wow.
thank you.